Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ilyasaq bin Hazami. Today, 11 December, 5:52 AM. I would like to present my lab 1. I am from class C ECE521 4C. So for the objective of the lab 1 is to write simple assembly language programs for the ARM microcontroller using data transfer and data processing instructions and addressing modes. And second, to execute the programs using an ARM Kyle editor, assembler or simulator. So let's jump to the lab. So let's start on the exercise 1. Exercise 1 wants to write a program that will store 03 into R0. So let me open my Kyle lab 1. So I will rebuild the Kyle. Program has 0 error. I will run the program. The exercise want me to store 0x30 into register 0. So I use the move instruction 0x30 into R0. So here is the result. And then copy the content of R0 to R5. So I use the move instruction to copy the content from R0 into R5, register 5. So here is the result. R5 is now 0x30. Next, save the data 0x45785612 into memory location 400030. So I need to save the data first into a register. So I save the data and the memory location into the register. The memory location I save into the R1 using the LDR. R1 is now the value of memory location. And R2 I save the data using LDR, and now R2 becomes the value of the data. And the exercise wants me to save the value into the memory location given. So this value in R2 will be saved in the memory location R1 using STR. The bracket is memory location. So run on the memory location for 0030. It's store the value of the data. So this is basically using the simple addressing mode. LDR start here is addressing mode. Addressing mode using the MOV here is addressing mode using the register addressing mode. LDR R1 using the addressing mode memory. LDR R2 is using the addressing mode memory. STR is using the addressing mode register. So the first exercise 1 has been successful. Next, we will go to the exercise 2. So for the exercise 2, I need to write and execute a program that will add 3 different values and save in the summation into R7. So for the exercise 2, I will rebuild the exercise to codes, and the coding have no error. I will run the exercise. So let's say the lab 2. So first I need to save all these 3 data value into different register. So I use the LDR. So the first data I save on the register 0, second data I save on the register 1, and the third data I save on the register 2. So next, I need to sum all the data value, and it's want to know the change on the CPSR as well. So I use the S to show the CPSR value. So first I summation for the first and the second data, which is on R0 and R1, and save it in R3. So this is the value, and the CPSR, the C is 1. It is because there is a carry. By using the calculator, we will add the value. Wait a minute. Plus with the second value. So as you can see here, there is one. This one is the carry value. The RT only save from 1F00. So here, that's why the CPSR, the C here is 1, because there is a carry. Next, I will add the summation of these first two value with the third value by using ADS also, so that I can see whether it has the next carry or not. So R3 is 1F10879. So here, this is the R3, and then we'll add with R2. This is R2 plus R2. So the program is supposed to have in R7 is 53691E29. Yes, 53691E29. This summation has no carry. Therefore, the C here has changed into 0 because it has saved the new value and changed its CPSR. So there is no carry. The C will become 0. Finish exercise 2. Exercise 2 has been done successfully. Next we will go exercise 3. For the exercise 3, I will rebuild the codes. There is no error. I will run the codes. So for the exercise 3, store the data to 936FEDA in R8. So I store the data in R8 using LDR. So here my R8 is the data value. And then perform the following instruction on the content of that register 4 times. Comment on your result. First is instruction ASR. So R8, ASR is arithmetic shift. R is right. So I will save the value of the content into register 1. It wants to shift arithmetic on the right 4 times. So the value is 02936FED. So this is how ASR works. ASR will shift the value to the right. This is the initial value. It will shift the value 1 into the right. So 1 will become on the right side, and here 0 will on the right, 1 will be on the right, and on the left side it will fill with zeros. So here actually is 0 zeros. So the blank side here is zeros. So next, it will start from the right. It will shift each value to the right. Here 1 will be here, and then 1 here will be here, and so hence this is all zeros. Because of here 0, it will be here for the next shift right, for the next ASR, and 4 times. This first, second, third, and fourth, and the fourth time will produce these values, and these values is as same as the Kyle. To check it using the calculator, so here is the initial value. We will use bit shift, arithmetic shift, and then click here for the right, here for the left. For our example, for the right, here we will use the word so that there is no access. There will be fixed 32 bit. So on the right, 4 times, click 4. Here is the answer to check using the calculator. Next is for LSL. LSL is logic shift left. So the value will be 936FEDA0. Logic shift left. How it works? It will shift the logical to the left. It is quite as same as the ASR, but it use the logic 1010 and shift it to the left is LSL. So one will be here and one will be here, and the right side will be filled with zeros. Because of this only LSS and not save the carry, so this one will be not save into the carry, therefore it will vanish. So 0 1 0, so this is the final value. So in the calculator, yes, it is the same value as the Kyle. To use it on the calculator, you can check the shift logical using the calculator by select the logical shift, and then this is the left side, so logical shift left 4 times. So here is the answer as same as the Kyle. Next is ROR. For ROR is rotational, rotate to the right. R is right, so it will be saved in R3. So this is the answer when we rotate the 1010 4 times. How it works, it will rotate. For example, here 0 here will be rotate on the right, so it will be on the right, and it will fill to the left, and 1 here will be rotate to the right. So next, for the this is first step, and the second step, this one will be rotate to the right and then will be filled to the left. That's why there is one here on the left. So third step, 1 here is 0 here will be rotate and fill on the left, 1 here will be rotate and fill on the left, and so on for 4 times. So this is the answer. The answer is supposed to be as same as the Kyle. 82936FED. Yes, it is the same as the Kyle. To use the calculator to check whether it is true or not, click the rotate circular shift, and then click on the right. This is the first rotate, this is second rotate. Click again for the third rotate, and click for the fourth time for fourth rotate. So we will get the answer as same as the Kyle. Hence, exercise 3 is successful. Now let's go to the exercise 4. Exercise 4. Write a program that will perform logical OR 0x6398 with 0x1dFE. Execute the program. So this is the program. Build. No errors. Run the program. So I save the first value in register 0 and the second value in register 1, and then I use the OR instruction and save it to register 2. We will get 7FFE. So how the ORs work? This is how the ORs work. This is the first value in binary for the first value, and this is the second value in binary. So the ORs work when either one of these two or both of these two has the value of 1, the answer will be 1. So 0 0 will be 0, 0 1, because of the second value has 1, so the answer will be 1. 0 1 will be 1, 1 1 will be 1, and so on. 1 1 will be 1, 0 1 will be 1. Here, the first value has 1 and the second value has 0. It is either one of these two has 1, the answer will be 1. So here will be 1. So the answer here will be supposed as same as the cal 7FE. 7FFE. So it is the same as the cal 7FFE. So the fourth exercise successful. Now let's go to the fifth exercise. The fifth exercise wants to copy 12 bytes of data start from memory location 4004,000 into location 4004,20. This location, if it has a value, will be saved in this location starting. This is the starting source and this is the starting destination. I need to set manually the content of the memory in starting source until 0B with 01, 02 and so on. Okay. Build the program. No error. Run the program. So because of this program, it needs to be copy 12 byte. So the most byte that can be copied is 4 byte. So I will run it 3 times. So I will use loop and counter. 4 times 3 is 12. So first I will store the location of first source destination in R1 and the starting destination memory in R2, and the counter is 3. So and then I will fill the value manually. So here is B. Yes, the last. So I wish the LDR, and this is post index memory address mode, post index address mode. So what it will do is, starting from 400 here, it will copy and save it into the register R3, and after it copy the value here and save into the register R3, it will add its decimal place, which is 4. Why 4? Because I want it to start on the next byte, on the next 4th byte. This is 0 1 2 3 4, 0 1 2 3, and I want it start at 4. Same goes to the STR. The data in R3 will save in the R2, which is the destination, and increase the value with 4. And next, it will subtract with the counter. So and then it will compare, is the counter has become 0? Is it the program has done 3 times? No. So if it's not, it will run again. So it will continue until all the value has been copied and pasted into the destination memory. So here is 20 until 20b. Yes. When the counter has equals to 0, which means it has run 3 times, and then the program will be finished. The exercise 5 is successful. Now let's go to the last exercise, which is exercise 6. In exercise 6, this is the program. I will build the program. There is no error. I will run the program. So it wants to compare data in the data in num into register 2. So this is num, and the num is set the number with value 3. Use EQU instruction. Num is equals to 3. So it wants to save the register 2 equals to num, which is 3. So R2 is 3. Next, it wants to compare either R2 is greater than 5. If it's greater than 5, store data in memory location 402000. If it's not greater than 5, I need to add the data with 60 hexadecimal in hexadecimal and store it in the new location, which is 402010. So first thing first, I need to save the memory location. First is the first condition, which is greater than 400200, and the second condition is if it is not greater. So the second memory location 402010, R4 and R3, the location have been saved. Next, compare the R2 with 5, and then I use the conditional branch BGT. GT is if condition greater than. R2 if greater than 5, it will go to store. The store is strb. It will save 1 byte, which is 3. This is only 1 byte into the memory location 402000, which is in R3. So let's run the program, which 3 is less than 5, so it will not trigger BGT. That's why it is orange. Because of it not trigger the BGT, it will not go to the store. It will go to the add. So I will add the value 3 with 0 at 60 and save it in register 2. So it's now 63. Then I need to store the value in 402010, which is in R4. Store the 1 byte. So this is the memory location 63 has been stored, and then it's finished. So the 6th exercise has been successful. So for the conclusion of the lab, all the objectives have successfully achieved. The simple assembly language programs for the ARM microcontroller successfully wrote without errors, using the data transfer, data processing, instruction, and addressing modes, and all the programs successfully executed. In this lab, The student successfully done the data transfer from register to memory and memory to register. The student also successfully done the data processing instruction such as shift instruction, which are LSL, ASR and ROR, the compare instruction CMP, and the conditional branch instruction. Last but not least, the student successfully used different addressing mode based on the exercises given, such as the post-index addressing mode. That's all from me. Thank you.